Hello, today I want to show you Samyang Tilt Shift, a lens full of secrets which we will uncover in a moment. Why are we starting so mysteriously? This tool is usually seen as a diorama effect source, and usually the knowledge of it stops here. In fact, this is only one of the less important features of this lens. Let's have a closer look. A typical prime lens is usually equipped with two rings, one to control depth of field and the other to control aperture. This lens has 6 other control elements: black knobs for tilt and shift, grey knobs locking tilt and shift, and also a button locking the tilted element rotation and a similar one locking the shifting element rotation. Focal length of this lens is 24 mm, and this allows focusing with the minimum distance of 20 cm. The depth of field scale is marked on the ring. The aperture of this lens is 3.5 and may be decreased to 22. The optical axis of this lens may be tilted by 8.5 degrees and shifted by 12 mm, and each of tilt and shift elements may be independently rotated by 90 degrees. Grey knobs allow locking the tilt and shift, which may be unlocked with the use of black knobs, or unlocked manually, which is useful, for example, in reportage photography. Black knobs allow precise tilting and shifting of the lens. This is facilitated by 2 scales, one in degrees for tilting and one in millimeters for shifting. Let's forget tilting and shifting for a moment. This is still not just a regular lens. The structure of tilt-shift lens requires that the image circle covers the intended frame in all possible combinations of tilting and shifting. The lens in a neutral position has enormous margin of frame coverage. Regular lenses rarely allow you to obtain equally good quality of a shot in its periphery as in the center, as the image circle is described on the frame field with only a slight margin. Tilt-shift guarantees that every part of the frame is equally sharp. This is particularly useful in panorama photography, for large printouts or screen magnifications. Stitch photos do not have any areas of inferior sharpness, and you obtain a consistent image. The structure comprises 16 lens elements with 2 aspherical elements and 2 low dispersion elements, which reduce aberrations to a minimum. Thanks to low focus distance and interesting effect of blur, this lens may be also used in small product advertising photography. It is also great as a macro lens with unusual short focal length. Let's use some of the magical capabilities of the tilt-shift lens. Let's start with shifting. This tilt-shift lens allows taking panorama shots simply and easily. Using a full-frame DSLR, all you need is a series of 2 shots to obtain in horizontal panoramas or 3 shots for vertical panoramas. In extreme positions of shift and, in case of 3 shots, 1 in neutral position. The focal distance of the lens with which such photo could be taken is 14.4 mm in case of a vertical panorama and 18 mm in case of horizontal one. The increase of resolution 167% and 200% respectively. For an APS-C sensor, this gain would be even higher. With tilt-shift lens, taking panorama shots is quick, so it's possible also take shots of objects with some movement. Anyone familiar with photography understands the fairly simple issue of the depth of field. In case of our lens, your intuition takes you nowhere. Let's have a look at this. Focal plane in a classic lens is perpendicular to the optical axis. Objects in front of it and behind it are out of focus. Even beginners know this. The tilt-shift lens allows manipulation of the focal plane. It simply has to be tilted by appropriate angle to include other elements from our example and make all of them appear in focus. When you tilt it upwards, only a small part of the shot is sharp. It gets even more interesting when you tilt the lens to the side. One part of the shot is sharp regardless of the distance of the elements. The other one is blurry. In practice, this is useful in particular in studio photography, where focal length does not cover the whole shot, but narrowing the aperture is for some reason not possible. Here we have another example of a pair of shots and magnification of an interesting fragment. Of course, you can also minimize the common part of the focal plane and the frame, obtaining the effect of short focal length. The option to correct perspective is another feature of tilt-shift lenses. Let's have a closer look at this. The problem of slanting walls in architecture photography is commonly known. This effect appears when you want to include the whole building in a shot and you incline the lens's axis. The tilt-shift lens allows correction of the slant through the tilt of the optical axis in relation to the sensor plane. You simply have to lever your camera and then shift the optical axis of the lens upwards to include the whole object in the frame. Using software correction, you can change the image already recorded, which obviously affects its quality. Let's compare details of the image after software and optical correction. Did you know that tilt shift can help you keep short shutter speed? Here is an example. Imagine that you want to have a few planes in focus and keep the shutter speed short at the same time. Theoretically, all you need is to narrow the aperture, but then you may find not enough light gets to the sensor. Widening the aperture will only get one plane in focus. The only option is to increase the sensitivity, which results in image degrading, or you can use a tilt-shift lens. The option to manipulate the focus plane will ensure that all planes will be sharp with the aperture you want. Do not have to increase the shutter speed, so splashing water from the fountain is not blurry. And this is exactly the point of this exercise. This is not the end of the magic yet. Did you know that one of the lenses can blur the background in two different ways? Let's go back to the tilt effect, when the lens is tilted to the right and the focus is in the center of the shot. Seemingly, you can see symmetry. Both sides are similarly blurry. Take a closer look at details. This is the image from the right side, and here from the left. In the first one, the structure is unclear. In the other, you can definitely see circles. When you tilt lens to other side, this will reverse. So you can choose the bokeh effect for each part of the shot, or even stitch two halves for the same blur effect. I wonder if you know who invented tilt-shift lens. Samyang? No. Maybe one of the other manufacturers. Let's have a look at this 60-year-old book of photography. This is a tilt shift from a century ago. At the beginning of the photography era, photos were taken with such cameras. Today, Samyang takes you back to those days. See you soon.